Hello and welcome to something new. We are calling it Solving Wicked Problems with Elegant Solutions. Wicked problems mean problems that have contradictory requirements, they have been around a long time without being solved, and generally any solution concepts that are considered are usually costly and complex. When we say elegant solutions, we mean ones that are simple, inexpensive, and without trade-offs or compromises. This is not about using Six Sigma, Lean, 5 Whys, random brainstorming, or checklists, which are all pretty boring. Don't you agree? These methods will give you incremental improvement, partial improvement, expensive solutions, complexity, or compromises. Not exactly exciting, satisfying, or impressive. Here is an overview of this process. We start with using a little-known, rigorous, objective method for understanding causal factors, called science-based causal analysis. In addition to exploring standard, concrete causes, we look at cognitive behavioral analysis. Aspects such as cognitive bias, emotion, and motivation can sabotage good technical solutions. Based on that analysis, many design contradictions are identified. Those contradictions are the focus of TREES, which uses proven strategies to have your cake and eat it too. That is, elegant solutions. Lastly, we will show how various artificial intelligence tools can be used to greatly improve the quality and speed of all of these steps. This entire process can be game-changing for many different disciplines and industries. Science-based causal analysis is at the heart of this whole process. This is objective and rigorous, much more so than common root cause analysis methods. It is driven by science, data, and research instead of brainstorming. The purpose is to find many ways to eliminate a problem instead of just finding a single root cause. This example is about pounding a pile into the ocean floor. Basically, it takes too long to correctly pound each pile into the ocean floor. Science-based causal analysis, also called physics-based causal analysis, is at the heart of this whole process. Otherwise, how would this normally be done? Brainstorm ideas and opinions? List the components or subsystems? Blame the operator? Or the pile driver should just pound harder? Using science-based causal analysis, we start with time to pound the pile into the ocean floor is too long. In this process for solving really tough problems, we take it slower. We first consider if there is a formula of some kind that determines how long it will take to drive it in. For example, time equals distance divided by speed. So the causal factors at this next level are speed and required distance. If we look at the speed or velocity of the whole process, another simple formula can be used. Speed equals distance per strike divided by the time per strike. When we look at the short distance driven, we can say the two basic factors are driving forces at the end of the pile. For example, momentum, spring rate, and the damping coefficient. For the resistive forces, we might simplify it by saying it is a function of the soil hardness and the size and shape of the pile tip. This causal analysis helps us to find many contradictions. In simple terms, we want what is seemingly impossible. That is, I want something to be this way, and I want the opposite way. If we could do that, what would be the ramifications? In our case, for the resistive forces, we said that one of the factors was the diameter of the pile. The pile is wide, but what if we made the pile to be narrow? If we did that, the pile may sink deeper over time. So we want the pile to be wide and we want it to be narrow without any of the negative ramifications of either setting. Seem impossible? For example, we could say a wide flat point is stable, but it is difficult to drive in. On the other hand, a narrow or sharp point would be easier to drive in, but it would not be as stable. If we make a graph showing the pile stability and the driving speed are both determined by the pile sharpness, it is easy to identify an optimum sharpness. However, we choose to think of an optimum as undesirable. That is, it doesn't completely satisfy both of the requirements. Put another way, people say, you can't have your cake and eat it too. But actually you can, and that is what you will see next. This is the tool set that brings everything together. to create the elegant solutions we have talked about, i.e. ones that are simple, inexpensive, and without compromises. The process is based on the study of hundreds of thousands of international patents to understand the common generic design strategies that enabled all the best patents, which are essentially elegant solutions. TRIZ is a very large body of knowledge that takes many years to master, but here we just utilize one of its most powerful methods in a relatively short period of time. Students who have been trained in this process have been able to resolve the contradictions in the pile driving problem with more than 15 solution concepts in less than 30 minutes. For example, if we think about the general strategy of doing something gradually, one thought is to use several small pointed piles, such that when they are all in, they could be bound together, so we have something that was easy to pound in, but it is also stable. If we think about the general strategy of transformation, one thought would be to make the point of the pile abradable, such that it is pointed when going in, but flat when it reaches the desired depth. If we think about the general strategy of segmenting, one thought would be to do something like blowing up the tip of the pile and thereby having a flat bottom pile. Another strategy is to think about doing something in another direction. Theoretically, we could attach a very flat object to the pile, so again it was easy to pound in, but we end up with a very stable situation. One other idea is to use the general strategy of making something non-uniform. That is, make the center of the pile pointed and small, but the outer part of the pile is left wide. So again, we have the full benefits of both settings without compromising. There are about 40 other strategies that can also be used. These strategies have been shown to resolve almost all contradictions and provide numerous ways of eliminating problems, as opposed to settling for incremental improvement. If we look at all the contradictions seen in the initial diagram, it is easy to identify more than 50 solution concepts to the overall problem. Bottom line, it can be much more fun and satisfying to generate elegant solutions instead of incremental improvement ideas. The unique focus in this method is the inclusion of the potential impacts of human cognition and behavior. We are referring to more than common human factors considerations, which are usually focused on human capabilities and limitations. Instead, we are looking at why a person behaves a certain way. As with the other elements of this process, this is driven by science and research instead of brainstorming. Let's pretend we are addressing the problem of there are too many rear-end collisions. In the past, this was addressed with better tires, an additional brake light, anti-lock brakes, and more recently, more sensors and warning systems. But it is not just about adding more technology or doing more fishbones in 5 whys, etc. We go through a process of considering different forms of cognitive bias, the resulting emotion, motivation, and social norms, possibly resulting in negative behavior. Beyond the branches of this tree that address various human factors, we look at why the driver chose to drive so close to the lead car. A couple of other contributors include that they believe the risk factors to be low, and/or they simply want to tailgate the lead car, each for a variety of deeper reasons. They could include such things as their history of tailgating has never caused an accident before, or the belief that the lead will not drastically reduce their speed. For why they would want to tailgate the lead car could include a variety of beliefs and emotions that we have all probably had. Luckily, we have the opportunity to utilize a wide variety of AI tools. When you learn how to write powerful prompts, you can get assistance with building the first draft of the causal analysis diagram, fill in any knowledge gaps, identify contradictions, use different strategies to generate solution concepts, and dialogue with the AI tool to make corrections and enhance understanding. This diagram attempts to summarize the entire approach: science-based causal analysis, cognitive behavioral analysis, contradictions, artificial intelligence, and elegant solutions with trees. Before signing up for any training, you should ask yourself these questions. Are you typically involved with fairly simple problems, such that Six Sigma and other tools are adequate for your work? Are you self-motivated? Are you usually satisfied with the solutions that you and your teams arrive at? Do you really want to do better? And are you open to slowing down and thinking more deeply? The next steps. You have already taken the first step by watching this overview. Attend a 2 to 4 day class to understand everything more clearly, look at case studies, and to practice. Begin a longer-term coaching program to become a confident and self-sufficient practitioner. We recommend a unique approach for people who want to take this seriously and begin a longer-term coaching program. It would be done as a small group or individually. 1 to 2 hours per week of online discussion, 2 to 3 hours of homework per week, including reading, practice problems, and a gradual transition to your own problem. 2 hours per week of additional, individual assistance at your request. No tests for certifications. It would take 10 to 14 weeks to finish the coaching, and everything will be very flexible. The benefits of this approach include no travel costs, no large disruption to your work schedule, better understanding and retention, no long, boring lectures, and the focus is on individual success and satisfaction. Contact David Tronis for more information and to start your learning.